So how will you calculate the pressure of a fluid at a particular height below the surface? For this, we will consider a beaker in which water is filled. So we need to calculate the pressure at a particular height. So for that, we will take a fluid element here. So this is the fluid element. See, and let us take that fluid element and consider all the forces acting on that fluid element. So this fluid element is at a height h. We need to calculate the pressure of a fluid at that point. It's a common knowledge that as you go down the surface of water, the pressure of water will increase. You can feel that in your ears. So in order to calculate that, we will draw a free body diagram. For that, we have taken a fluid element here. And on the fluid element, see at the top, the pressure exerted by the fluid is P, and at the bottom, it is P plus delta P. At the bottom, pressure slightly increases. That is delta P. See, the fluid element's cross-sectional area is A, and the height of the fluid is delta Y. Here we have taken the Y in the uh, downward direction. So the coordinate system here we have taken like this, that is X and Y. So this fluid element is at rest. That means all forces are balanced and the fluid element is in equilibrium. So you can write a force balance equation here. So see, before writing the force balance equation, there is one more force acting, that is downward, that is due to the weight of the fluid. See, the volume of the fluid is A into delta Y. This is the volume of the fluid element, and G is the acceleration due to gravity, and rho is the density of the fluid. So density into volume into acceleration due to gravity will give you the weight of the fluid. So the forces acting are pressure force acting on top, and there is a pressure force acting at the bottom, and also there is the weight of the fluid. So if you write a force balance equation for that fluid element, since the fluid element is at rest, we will get an equation like this. That is P into A, that is the pressure force acting downward, and rho G A into delta Y, this weight of the fluid element acting downward, and also P plus delta P into A, that is the pressure force acting downward. So we will do a force balance equation. Okay, let us see that fluid element once more. The fluid element is of height delta Y. So the pressure is acting downward, and P plus dP, delta P, is pressure is acting upward, and the weight of the fluid is rho G A into delta Y, that is acting downward. So let us write the force balance equations for this fluid element. Since the fluid is at rest, all the forces will be balanced. That is P into A plus rho G A into delta Y is equal to P plus delta P into area. This is the pressure force acting downward. This is the weight of the fluid, and this is the pressure force acting upward. Okay. So if you solve that, you will get delta P is equal to rho G delta Y, because the area gets cancelled off, and that means if you balance the LHS and RHS, you will get delta P is equal to rho G delta Y. That means delta P by delta Y is equal to rho G. So if you take the limit, that is it is Y, limit y tends to 0, delta P by delta y is equal to dP by dy. See, we have calculated this equation based on the idea that y is taken downward. Okay, usually in a coordinate system you can see that usually y is taken upward, that is x and y, but for convenience we have taken y downward. So we want to change it to this coordinate system. If you change it to the new coordinate system, you will get delta P by delta y is equal to minus dP by dy. That means the y will be in the upward direction. So dP by dy is equal to minus rho g. This is the variation. This is the formula for calculating the variation of pressure as you go down the fluid. So this is the final equation, that is dP by dy is equal to minus rho g. So this means that if you go up, the pressure will get reduced by minus rho g. As you go down, pressure will get increased by rho g. So let us see what is the pressure in a fluid at rest, how it varies with height. We have already derived an equation for that. So you can see that here. So if you consider a height h at a depth h, then pressure will be equal to P atmosphere plus rho gh. This is the formula we will use. So this is the total P absolute pressure acting here, that is equal to atmospheric pressure plus rho gh. This is the formula for calculating the hydrostatic pressure.